Hello, everyone. Good morning. Yes, mine's a little bit too loud, so you want to hold it close to you. My name is Ishan, and I'm a tech lead at Tinder. I do a little bit of mobile architecture, design, infrastructure for devs there. And today I'm joining Matt in talking about pagination at scale.
Yeah, so the context is I gave a talk at droidcon SF, reimagining pagination. After the talk, Victor Wu, who's a senior manager at TikTok, that's much better, and I think Ishan's manager, reached out to me and said he was interested in exploring using it at TikTok, how they could potentially get involved. He connected me with Ishan, and then we started kind of collaborating and going from there. So before we go into kind of the conversation about TikTok's evaluation of this, what it might look like at TikTok, I'm just going to go very quickly through the DroidCon presentation in San Francisco, just to set the stage. So if you go to the next slide. So this first slide is the core things that I was excited about back in June. So the first thing is that it is a UDF first architecture. The second thing, a new concept of a self-updating item. It's been renamed to an updating item. We'll go into that more later. This operation pipeline for on-the-fly data transformations, these could be things like filtering, deduplication, validation, sorting if you choose, grouping, tons and tons of customization points, and then support for local and remote mutations, because under the hood it's using Store for data loading, caching, and updating. And then it is compatible with Android X on the Kotlin platforms where Android X is supported. And then, so it's powered by Store, like I mentioned, which is one of the libraries under Mobile Native Foundation. Obviously, we're using some of Android X's stuff, including Compose Runtime. And then I can go into this quickly. So if you go back a slide. Yeah, so this is a post from Jake Wharton about how Compose UI versus Compose Runtime. And the core thing here is, in his words, it's a general purpose tool for managing a tree of nodes of any type. The nodes don't have to be UI related at all. The tree could exist at the presentation layer as view state objects, at the data layer as model objects. And then I think he concluded somewhere, basically the use cases are really only limited by your imagination. And I thought that was really cool. And that's what inspired me to try using Molecule for our paging solution. And so Molecule, under the hood, again, from this talk by Jake, taking the Compose engine, turning it on, having it emit new values into a state flow for consumption. Compose handles recording values, and it decides if your function needs to be recomposed. It handles recomposing and emitting the new value. And like I said, the use cases are really only limited by your imagination. Okay, so since DroidCon SF, we wrote a design doc. We shared that with folks from a few different companies. If you go to this site, it's just a Google Doc with a bunch of comments and reviewers and so forth. If there is time and interest, we can pull it up and we can kind of go into the details, but it's massive. All right, so the next 35 minutes, we're going to talk about what paging looks like at TikTok, what some of the unique challenges are at scale. That won't be only specific to TikTok. It will be TikTok, Uber, Tinder, so on. Comparing Android X versus StoreX, and then we'll deep dive into some of the technical things like UDF, transformations, performance, and flexibility. All right. So with that, let's transition to, what TikTok looks like. And so kind of taking a step back, I think it's important to understand the product and the use cases at TikTok, and for us to have a shared mental model on, what the app looks like, what the user experience is. So with that...
All right. So if anyone's ever used TikTok, you're familiar with this screen, which is the first screen you see when you're looking at some videos, and you just swipe up through this skull. The other one is the search page, so you can start searching for stuff, which, if you see clearly, has got like horizontal scrollable rows and then also vertically scrollable stuff. So you've got heterogeneous data that you're now dealing with and paginating upon. And then we've got the Discover page, which again has similar problem. So you can swipe up, you can also swipe left and right. And then next to that is a profile screen, where now you're looking at the data for a particular account, which looks fairly simple, but if you see that now it's actually tabbed. So on the profile itself, you've got a grid of information, which can change fairly quickly for like popular accounts, because you're now seeing how many views every video or TikTok has got, or the short has got. And this is kind of the scale at a high level where we're dealing with pagination. And the reason why StoreX even came into the conversation is that we want to make sure that the adoption that we make at the next step is scalable, works for us for a long period of time, is easily usable and consumed by a lot of engineers, lower learning curve, but we'll dive into that in a little bit of a detail moving forward. So shifting focus from the visual aspect of it, I think we want to now see what challenges we face at a technical level when we're considering a new library or even a solution, even if it's not a library or solution, for our engineers, for our product. The first thing is UDF, so unidirectional data flow is at the heart of it, or the forefront of it, because we compose screens, not with Compose particularly, but like we have a MVVM-like architecture, which we've internally written, and it's very similar to a lot of what exists out there, like Ribs is there, it's inspired from that, or Trio that Airbnb launched and things like that. So we want to adhere to that model, and we don't want to move away from that. And we want to make sure that data flows in one direction all the time. This allows us to kind of minimize the impact that the product engineers would face if we were to introduce a new paradigm or a library into our code base. And then we also want to make sure that we've got predictable state management, because the way when you're writing things at this scale, you want all your engineers across the teams, across the pods, to think the same way. And with predictable state management, you can also debug your apps easily. You can build the features in the same way possible. And then you're also improving kind of performance by limiting the unnecessary updates that happen if you're going back and forth between the inputs and the outputs. Testing becomes much easier because now you know how your data is flowing, so you don't have to think about that, and you can actually be creative about the type of tests you want to write. Error tracking also becomes easier. In case you've got problems, you can easily replay how the data would have flown, and then where you are able to isolate the error to. And then you can also avoid circular dependencies, because you now know data is, again, flowing in one direction. For the second part, I think data redundancy, or transformations, as we call it in StoreX. Data redundancy is one of the biggest problems I have personally faced at TikTok, and also other companies that I've worked at, or products that I've built. Multiple features across the app, and we'll see examples of that, want to talk or basically show some sort of the data which is a part of the same domain. And the information is different across as you transition through the flow. One example of that would be dating app. This is a screenshot of Tinder. So what you're seeing here is a swiping stack. Think of this as a recommendation that Tinder gave you of a person you may want to swipe left or right on. But there's only so much information that's just visible at the first glance. When you move through the pictures, or if you try to go into a profile of a user, the information changes. It actually adds to the same recommendation that you had. But the thing is, when you're fetching those initial recommendations, you don't want to fetch everything at once because you want the experience to be smooth and fast, and you also want to be conscious about the memory pressure you're going to create. And so this is where pagination at scale becomes a problem, because you also want to be able to show this information immediately as soon as the user goes in, but you also cannot fetch everything at once. Similar problem happens at a travel booking app. So this is a screenshot from Booking. This is the screen that you get to when you search for a property. Could be a hotel, like a house or something like that. And then you scroll through that, you paginate through the responses. But as soon as you click on one property, now you want more information about that property, which again is a scrollable feed with both images, which is like a staggered grid, and then also a lot of information about the property itself. And it doesn't just stop there. You now also want to augment this information after scrolling through when you want to select a room. So at the same screen, when you click on select rooms, now you're paginating through the rooms that a property has to offer. And those could be of multiple types, could have multiple different rates based on what the property is offering. So this is kind of the landscape that we're dealing with when we're thinking about pagination and kind of a data layer solution at scale. And this is a problem I think most of the apps would be facing, that you fetch a particular type of thing when you're trying to show the list or the feed. And then as you go in, now you want to expand on that. And then what starts to happen is some team or some feature wants to mutate or modify that data. But by the time you come back to the results, those updates may not have synced, some sort of corruption. So people start making their own small entities that they now start dealing with. And then you're hitting at endpoints multiple times for the same thing and trying to fetch or refresh that data. These are kind of the things that we wanted to make sure the next solution that we come up with caters to, as where the transformations from StoreX kind of come into play. Performance, again, is one very key aspect, especially at scale, because even if you look at percentages, a 0.1% or a 0.5% change that's negative or that's going to hurt a business at 1 billion active users a day is going to be a very, very big number. And when you multiply that or represent that in terms of dollar figures, it's going to be huge. So performance has to be thought through from the very beginning. We don't have room for error there. Of course, whenever we want to make these changes, we will do that through an A/B test and stage rollout, controlled way. But still, we want to minimize any problems with performance. And I think Matt can also talk a little bit about what performance means from StoreX's perspective.
Yeah, I definitely can. I think we're talking about that later, though.
Okay. And then the last part is the flexibility. Like we said, we want to accommodate for a diverse set of use cases. And we also want to make sure that anything in future that we want to develop still can fit into our paging use case that we build today. Other than that, we want to make sure that teams don't feel tied down by this new way of doing pagination at scale. And so we want to keep all of those things and evolving requirements in mind when coming up with a solution. Since Matt is the original author of StoreX, he's done extensive research around what exists out there and what problems he wants to fix that come up with other libraries. And he's done like a comparative study between AndroidX and StoreX, which I think he should now share with you all.
Yeah. So the context, I guess, for even starting to work on this is Store received a lot of feature requests for either working with AndroidX paging or having its own paging solution. The core issue is that users didn't want to have these two different dependencies that they have to manage and maintain or maintain the connections with. So Um, our first thought was like, let's just hook into paging as much as we can and just use that. We didn't want to build our own thing, and we just had these issues that we were hitting. So the first one, UDF, we've already talked about it here. This is an issue from Google that has been open for a few years. The issue is that with Compose specifically, you can only collect the lazy paging items in the UI. You can't do anything at the view model layer. And that just doesn't work with UDF, right? So that was a big thing. The next issue that we had, so this one is really interesting. Sorting is, it doesn't make sense with paging. In most use cases, there are some use cases where it might make sense. For example, if you have like Reddit, where you know that when you pull it, it's going to be deterministically ordered, and the order is guaranteed. If it's something like TikTok, for example, where the items are like changing in order, having sorting the paging data just it doesn't work, and that's why Google said that I forget. Yeah, they won't fix. It's infeasible. So that's one part of it is the sorting, but then the transformations that they support, like filtering. Like if there's time and interest, we can pull up the Android X docs, but again, that's all at the UI layer. You can't do that at the view model or the interactor, the presenter, whatever. It's all like in the UI. The third one is local mutations, and so they have this issue for self-updating paging results, and that's where we got the name for updating items. The idea is that when a single item updates, the data source needs to be invalidated. And so, like with Compose, if the keys are right, the recomposition is still handled by Compose, but you still need to do the invalidation of the data layer. So that's an inefficiency that we were trying to address. So those are the three issues that we were trying to tackle. The differentiating issues. So kind of diving into the UDF. This is, if we go to the next slide, we'll see what the pager looks like. So it just emits the state flow of paging state. We'll look at the paging state next. The paging state is a list of IDs. So all of the data is normalized. We use these updating items. The updating items are like an item level view model that you can just, it will be provided when you create the composable. And then you have access to these different load states. UDF, right? So your state's going down, events are flowing up. These are some example actions where you can like process a queue, you can skip the queue, you can enqueue something, you can invalidate data, and so on. There's lots of different customization options that we'll get into later. Yeah, so this is an example presenter. This is a circuit presenter. If folks here have worked with circuit, I love circuit. So all of my sample stuff is with circuit. And so the presenter is just taking in the pager, it's collecting the paging state, and then it's emitting it to the UI with an event sync. And it's very clean. So next, transformation. So we have this this concept of an operation pipeline. So an operation is it's like a plugin almost, where it has this internal function whether it should be applied, and then you apply it. And so an example of that would be like if we have the like a Reddit app, right, where you can sort by top, best, hot, new. The operation would be so the operation would be like if it should always apply, just return true. You can have whatever logic in there you want. And then whether to apply it, again, it can be as simple or as complex as you want. But for this case, if we're sorting the items by, I forget what exactly this example is, but if we're sorting it by top, right, we're looking at compare by descending. So it's looking at the favorite count, and then it's looking at the created count. So it's the top items by the descending date, and you have total control there. Next, we'll look a little bit at the performance stuff. So there are lots of performance considerations that we thought hard about. The first one, efficient data loading and caching. And so there's lots of stuff we can talk about here, but mainly it's just using store and Guava caching, which I didn't write store for. Mike Nakimovich and Yeet Boyar primarily wrote it. And then Guava cache, obviously, I didn't write that either. Minimizing recomposition. So we've talked about the updating item concept to isolate the item level updates rather than invalidating the data source and passing things down the tree. It's just updating at the item level. It's leveraging Molecule for efficient state management. Next, different like memory optimizations. There's so much here that we could talk about, but we have this concept of an item snapshot list. So each time the paging data updates, we take a snapshot, we make it available to the consumer, and they can have different strategies for working with it. Concurrency and thread management, obviously, lazy evaluation, computation, different like algorithms. All the code is, we can share it, but and then placeholders and smooth scrolling. This was really interesting too, because you don't know like when the data is going to come back, and so you have to keep track of the different, you have to keep track of where things are, maintaining like a responsive UI. And so this is just like a quick look at the self-updating item API, where it's like a view model at the item level. It's more granular view model, where it has its state, and then it can take in an event. All right. So we ran benchmarks, or I ran benchmarks before droidcon SF. This slide has been modified slightly because I'm not sure if Jesse is here, but Jesse told me to remove the trophy. I had trophies and I removed them because we're not, I guess, there yet. But yeah, so basically like things were on par with Android X. Pretty much everything. The thing that we did really well was janky frame delays and the recompositions because of Molecule and the updating item concept. And then flexibility. So Ishan talked about like why flexibility is really important with these big companies, because we need to have things standardized while also allowing for accommodating like diverse use cases. So we have so many customization options here. Like you could have launch effects, things that happen when the pager's created. An example would be like initializing custom logging, hydrating the cache. There's middleware APIs. So like imagine you pass in a request, you want to add different like headers, for example. Headers or obfuscation. There's also side effect APIs. So this is whenever we take a snapshot of the paging state, you could have these side effects that fire off. This is useful again for standardization while allowing different teams to do their own thing. We have fetching strategy APIs like whether to fetch forward, whether to fetch backward. We're always tracking the states, the pre-pending state, the appending state, a refresh state, and an invalidation state. So we're tracking all of these things and then making decisions based on this fetching strategy. Different error handling strategies. So like whether to ignore it, whether to pass it through, whether to just keep retrying with, like, you could do like a back off strategy. And then just kind of closing out, there have been so many people that have been involved at various points. So just wanted to say thanks here. Mike and Yeet for Store, for all the Android stuff, feedback. Ryan Harder gave me so much feedback on this. I know he's not here, but if he does watch this, thank you, Ryan. Ty Smith for Mobile Native Foundation support, feedback. Victor for support at TikTok, for connecting us. Johan and Patrick at Uber for feedback. And then Jesse and Jake and the Cache team for Molecule. So I did a podcast. We did a podcast yesterday about like getting in touch with StoreX stuff. We have a Kotlin channel. We have obviously GitHub, Android study group. If you want, we would love to have more people involved, more people helping. If there's any interest, people want to be involved, definitely reach out. We have funding from Kotlin Foundation, where we have like bug bounty programs and like mentorship programs that we are trying to figure out. So definitely reach out. Was that it? That's it. Thank you.
Thank you.